Hey everybody, Mr. Judson here. So last semester we talked about something called the mean value theorem for derivatives. And you probably don't remember this. If you do, that's great. But what we did is we said if we've got some function f of x, so I'll just call this red curve f of x, on the interval a to b, we could find the average rate of change, which is really just the slope between 2 points, between this point and this point right here. So this black line has a slope to it. And then what we said is that somewhere along this curve, there's got to be a point that has that exact same slope, as long as the function is continuous. So if I was to just grab this black line and slide it down, it kind of looks like there's a whole bunch of points there, but right about here, there's a point that has the same slope as that average rate of change. And that would be our C value. So in our book they said there's a C value guaranteed by the mean value theorem where the slope of a tangent line will be the same as that average rate of change. Okay? Well, there's a mean value theorem for integrals as well. And so that's what we want to take a look at for today. Okay? So let me get that set up for you guys. Alright, so what we want to look at for today is the mean value theorem for integrals. And how is that different from the mean value theorem for derivatives? Okay? Well, we know that when we do an integral, what an integral represents is the area underneath the curve. That's what we're trying to figure out. Well, the mean value theorem says, so again, let me just draw a line. This time I'm going to draw a horizontal line. I'm going to draw it from right here over to, so from A to B. Okay? And what we're saying is there's got to be some point along this curve where I can move this black line up and down, and the amount of extra area that I got right here is equal to the area that I missed over here. Okay, I don't know where that point is, but there's got to be some point, where that happens. Maybe someone looks at this and goes, no, I think there's a little more area here that was missed than here. I go, okay, let's just move this up a little bit. Oh, come on. There we go. How about right there? And someone goes, well, no, that's a little too high. Okay, fine, move it down a little bit. I don't know if I can do this. If I click on that, if I had a keyboard, I could do up or down arrows until I find the spot where this area that I got that's extra is exactly equal to this area that I missed. Okay? I'm not saying I hit that area, I'm just saying there's got to be a place somewhere where that happens. Okay, where the two balance out. And when I find that, this point right here, where that occurs, that's my C value. Okay? Now, think back to, maybe you guys have heard these words before in, let's say, middle school, the mean, median, and mode. Right? The mean means the average of something. And that's really what we're saying right here, is this is the average height, the average y value for this function. If I take all the y values along this curve from A to B, and there's a lot, right? There's an infinite number of them. If I take them all up and divide by however many I added, this black line represents that average value. Okay? We'll get asked some questions today where they say, what's the average value of this function? That's what it is. It's where that black line occurs so that the extra area I got here is equal to the area that I missed over here. All right? That black line, the y value of that black line is our average value of this function from A to B. Okay? So how do I find that value? Well, I know that to find the area of this rectangle right here, it's one big rectangle, I would just do base times height. Right? Well, what is the base? I don't know, whatever b minus a is. You know, if this is at 2 and this is at 7, 7 minus 2 is 5. That's the length there. All right? So I know that the area of this rectangle is equal to b minus a, there's our base, times the height, which is just our average value. Base times height. But we also know that to find the area underneath a curve, because remember, the area underneath this red curve is equal to the area of this rectangle, right? Because we've positioned this horizontal line in a spot where this extra area that we got is equal to this area that we missed. All right? So if the area of that rectangle is equal to the area underneath the red curve, well, I know how to find the area underneath the red curve. That's the integral from a to b of f of x dx. And that's going to equal b minus a times this average value. Well, if I want to find the average value, how do I get that by itself? I'm multiplying it times b minus a. I just need to move this over here and divide. Right? So if I divide this whole thing by b minus a, it's really the same thing as out in front. I'm just going to write times 1 over b minus a. So 1 over b minus a times the integral from a to b of f of x dx, that equals the average value. All right, so that's one of the things they're going to ask us to do today, is to find the average value of a function, and that's how we do it. The second thing they're going to ask us to do is to figure out at what c value does that average value occur. At what c value does that average value occur? Well, in that case, what I want to do is just take my original function, whatever the equation of that curve is, and say, where does that equal the average value? Right? If I have an equation for this curve, I just want to set it equal to the average value and then solve for x, and I found that c value that's guaranteed by the mean value theorem for integrals. Okay? As long as this function is continuous, this horizontal line has to cross this curve somewhere, and that c value is what I'm looking for. All right, let's try a problem here. All right, so I'll do the first one here, and then I'll let you guys try the second one. So using the mean value theorem for integrals, they want us to find the value of c, or values, there could be more than one, it's possible. Find the value of c, guaranteed by the mean value theorem for integrals for the function over the given interval. So the first thing I need to do is I need to figure out what the average value of this is. All right? So I'm going to do number 48 here. So I know when I graph a square root function, it looks like this. And we're going from 4 out to 9. Okay, we're looking at this area right here. All right, so I got to know what the average value is first. So I'm going to say that the average value equals 1 over b minus a, so 9 minus 4, that's 5, times the integral from 4 to 9 of x to the 1/2 dx. So let's see, if I add 1 to the exponent, I get x to the 3/2, divide by 3/2, means multiply by the reciprocal. We're evaluating that from 4 to 9, and then I got to divide it by 5. That's going to be my average value. All right, so let's see, if I plug a 9 in here, square root of 9 is 3. Cube 3, you get 27. Then divide it by 3, you go back to 9, times 2, that's 18. So I got 1/5 of 18 minus what I get when I plug a 4 in. So put a 4 in, you get, the square root of that would be 2. Cube it, you get 8. Times 2 is 16, so 16/3. And I just got to figure out what that's equal to. So I'm just going to put that into the calculator real quick and see what I get. So if I punch that into the calculator, I've got 1/5, so I'll do 1 divided by 5 in parentheses, times 18 minus 16 divided by 3. And it'll give us an exact answer, 38/15. So there's our average value. So now I haven't really done everything that the directions have asked. It says find the values of C guaranteed by the mean value theorem. Where does this function equal 38/15? That's what I want to figure out now. So my function was just the square root of x. So I want to be able to say, where does the square root of x equal 38/15? And it's got to happen somewhere between 4 and 9. Okay? So to get x by itself, I just have to square both sides. So x equals whatever 38/15 is squared. Let me go back to my calculator. So let's see, we'll clear this. I want to take this answer. I guess I should put it in parentheses. And I want to square that. And there's what I get. C equals 1,444 225ths. 1,444 225ths. Is that inside the interval 4 to 9? I believe so, but let's just double check. If I put a decimal point there, yeah, 6.417. So it is between 4 and 9. It's got to be in there somewhere. Okay? There it is. C equals, oops, 444 over 225. All right, you guys try the next one. F of x equals 9 over x cubed on the interval 1 to 3. We want to find the C value guaranteed by the mean value theorem. Okay, go ahead and give it a shot. Alright, so my average value, I want 1 over b minus a. So 3 minus 1 is 2, so that's going to be 1/2. The integral from 1 to 3 of 9x to the negative 3 dx. So you could move that 9 out right away if you want. It's a number. We can move numbers outside of an integral. I think I'm going to go ahead and do that. So I've got 9/2, and then when I integrate this, x to the negative 3, I'm going to add 1 to the exponent, so that becomes x to the negative 2. And I'll divide by that new exponent, and then evaluate this from 1 to 3. If you're ever worried about, is it okay to move this number out? For some reason it doesn't quite look right. I think I can, but I'm not really sure. If you're ever unsure, don't. Just leave it in there. Because there's nothing wrong with leaving it there, right? If this would have been 9x to the negative 2 over negative 2, I'd be just fine, right? Okay, so let's see, if I plug a 3 in, well, first of all, let's fix the negative exponents. So I've got 9/2 times, if I drop that down below the fraction bar, I've got a negative 1 over 2x squared evaluated from 1 to 3. Okay, it doesn't matter if the negative sign is in the denominator or the numerator. So now if I plug in a 3 and square it, I've got 9 times 2, that's 18. So I'm going to get a negative 1/18 minus what you get when you plug a 1 in. So if I put a 1 in and square, I get 1 times 2, that's 2, so 1/2. And I've got a negative 1/2. Be careful of those negative signs. You know, we're subtracting whatever I get for an answer here. And the answer I get is negative 1/2. Okay, still have my 9/2 out in front. And so let's see, if I'm going to add 1/2, that's the same as 9/18. Okay, got to get that common denominator. So a negative 1 plus 9, that would be 8/18. So 9/2 times 8/18. Let's see, if I do a little bit of cross-canceling here, that becomes a 1, that becomes a 2. 8 divided by 2 is 4. 4 divided by 2 is 2. There's our average value. So now, where does that average value occur? If I was to graph this, I don't even know what this would look like. I'd have to punch in the calculator. Okay, you guys can do that if you want to see it. But all I really care about is where does 9/x³ equal to? Where does it equal that average value? Well, bring that x³ over here and multiply. Bring the 2 back and divide. And then take the cube root of that. So x equals the cube root of 9/2, or the cube root of 4.5. Kind of feel like I want that as a decimal number. So I'll grab my calculator and I'm going to do, let's see, clear that, I'm going to do 4.5. And if I want the cube root, it means I'm going to raise that to the 1/3. Here's what I get, 1.651. So, you know, I always want to think, is that in the interval that they gave us? The interval was 1 to 3. Okay, so 1.651, it is in between those two numbers. So that's my C value. Guaranteed by the mean value theorem. All right, so let's go ahead and try this one. Same idea, we're just doing this with trig. All right, you guys give it a shot. All right, so the average value of this thing is going to equal 1 over b minus a. So that's 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of the cosine of x dx. So to divide by a fraction, I'm just going to flip that over, so that'll become 2 over pi. Integral of a cosine, let's see, I would have taken the derivative of a sine to get to a cosine. So the integral of a cosine is a sine of x. And I'm evaluating that from 0 to pi over 2. So if we think unit circle, there's 0, there's pi over 2. So the sine of pi over 2 is 1. Sine of 0 is 0. And I've got 2 over pi times 1. So my average value is 2 over pi. So now we have to figure out, okay, where does that C value occur? You know, the C value that makes our average value equal this. This is actually my Y value here, right? If I think, what does a cosine curve look like? It looks like this. And right here is pi over 2. So we're going from 0 to pi over 2 and we're trying to find the average value. There's my average value right there. Okay? I mean, what is that? This is 1 right here. So let's see, if I take my calculator, clear this, and I want to do 2 divided by pi equal to, there we go. So 0.64 about. So what that means is, if this is 0.5 and 0.64 is right about here, so if I make a mark going across, there's my C value that I'm looking for. Okay. So where does the cosine of x equal that average value? So cosine of x equals 2 over pi. To find the angle, I want to say x equals the inverse cosine of 2 over pi. So I'll do that on the calculator. So let's see, green diamond cosine of 2 divided by pi, 0.881. And that's our C value that's guaranteed by the mean value theorem. It is between 0 and pi over 2. Okay, pi over 2, remember that's 1.571, half of pi. And so we're in the correct interval. So our C value is 0.881. There we go. All right, you guys, that's what we have for today. I'll get you guys a homework assignment. All right, so assignment number 3, week 3, we're on Wednesday. We're doing page 293 and 47 to 59 odd. So let's see, tomorrow I'll see you guys in class. I'll just kind of work from my desk down in Oregon, and I'll take the document camera down with me, and so we'll be able to meet together as a group on Thursday. All right, you guys, take care. I will see you then. Stay safe. Bye.